Today we're going to walk through the Unit 3 test review. This is all about parallel and perpendicular lines. So let's go ahead and jump in. For these first few, all we want to do is identify what pairs of angles we have. Now, if you can't do this, everything else is going to be horrible. You have to be able to identify what relationship the two angles have and what that means for them before you can set anything up and solve anything. All right, for number one, these are corresponding angles because they are in the same place in the different intersections. Both of them are in the lower left area of their respective intersection. For number two, these are on different sides of the transversal, but they are between our two lines. So they're between these two lines, so they are alternate interior angles. For number three, these are on different sides of the transversal, but they are outside of our two lines, so they are alternate exterior angles. And for number four, these are on the same side of the transversal and between our two lines, so these are same side interior angles. Now for our next few, we are shown that our lines are parallel. Remember, that's what these triangles stand for. So in number five, we have alternate exterior angles. And when the two lines are parallel, alternate exterior angles are congruent. So our question mark equals 73 degrees, because when things are congruent, we set them equal to each other. In number six, these are alternate interior angles. Those are also congruent. So our unknown angle is 65 degrees. For 7 and 8, we start the same way, only now we'll set up an algebraic equation to solve, and we're trying to find x. In number 7, these are corresponding angles, and corresponding angles again are congruent, so we set them equal to each other. 22x equals 110, so x equals 5. In number 8, these again are alternate exterior angles. So they are congruent, so we can set them equal to each other. 10x minus 4 equals 76. Add 4 to both sides, so 10x equals 80. And then divide both sides by 10, so x equals 8. Now, our next section is done the same way, although the wording is a little bit different. Remember, we had the converses of all of those theorems in the postulate about our angle pairs. So the original theorems and postulate said if these angles are congruent, then the lines are, if the lines are parallel, then these angles are congruent or these angles are supplementary. Our converses say if we know the angles are congruent or the same side interior angles are supplementary, then we know the lines are parallel. So in this next group, we're trying to make the lines parallel, but the way we set it up is identical. Okay, in number 9, these are same side interior angles. If we want the lines to be parallel, these have to be supplementary. I'm going to call this one x. So x plus 55 equals 180. So that missing angle has to be 125 degrees to make the lines parallel. In number 10, these are alternate interior angles. So if we want the lines to be parallel, then that missing angle has to be 72 degrees. It has to be congruent to the angle we're given. 11 and 12, same idea, only we've got algebra that we have to do. In number 11, these are alternate interior angles. So they're congruent, so we can set them equal to each other. 14x plus 2 equals 100. Subtract 2 from both sides, 14x equals 98. Then divide by 14, so x equals 7. On number 12, these are same side interior. These are the special ones, remember, that add up to 180. So we need to set these up so that they add together to get 180. So negative 4 plus 19x plus 18x minus 1 equals 180. Combine like terms. We've got 37 x's total, and then we've got a negative 4 minus 1, so we've got minus 5. We'll add 5 to both sides, so 37x equals 185. And so x will be 5. We divided by 37. All right, for 13 and 14, we want to solve for x. Remember, the three angles of a triangle add up to 180. So in number 13, we'll add all three of them up to get 180. 60 plus 80 plus 3x plus 4 equals 180. Now we've got three like terms there. So 60 plus 80 plus 4 is 144. So we combine our like terms. Subtract 144 from both sides, we get 3x equals 36. Divide by 3, so x equals 12. In number 14, remember, this is 90 degrees. That's what that box means. Okay, but we also know that if we have the two acute angles of a right triangle, they have to add up to 90. So there's actually two ways you could set this up. You'd get the same thing either way. So we could say x plus 41 plus 55 plus 90 equals 180. So that's adding all three up. That's how we did number 13. Or we could just say x plus 41 plus 55 equals 90. Either way, you're going to get the same answer for x. So when we combine these two like terms, we'll have x plus 96 equals 90. So x equals negative 6. And remember, it's okay for x to be negative as long as when we plug it back in, we don't get a negative number. All right, for 15 and 16, we are using the exterior angle theorem. Okay, that tells us that these two angles, okay, the two remote interior angles, add up to get that exterior angle. So 80 plus 5x minus 5 equals 11x plus 15. So we can add those two inside angles to get the exterior angle. Combine like terms. So let's put these two together. That'll be 5x plus 75 equals 11x plus 15. Let's move all our x's to one side. So we get 75 equals 6x plus 15. Move all our constants to the other side. So we'll subtract 15. 60 equals 6x. Divide by 6, so x equals 10. This doesn't tell us to find x. Make sure you read the directions. This tells us to find angle RFG, which is this angle, the blue angle. So the measure of angle RFG equals 11 times 10 plus 15. That will be 110 plus 15. So the measure of angle RFG equals 125 degrees. Number 16, we'll start with the same setup. The two remote interior angles add up to get the exterior angle. So 75 plus 5x minus 5 equals 15x. Combine like terms, we get 5x plus 70 equals 15x. We want to move all our x's across to get them all on one side. So 70 equals 10x. Then we divide by 10, so x equals 10. That's not what it tells us to find. It wants this angle. The measure of angle E equals 5 times 7 minus 5. That'll be 35 minus 5. So the measure of angle E is 30 degrees. Now our last few problems are straight algebra review. Okay, we took time to do these in class, but they were not new to you. All right, this whole concept you covered in Algebra 1. We want to write the slope-intercept form of the equation of the line. That's the y equals mx plus b. We are given in these first two, we're given m because the slope is m. We need to find b though. So to find b, we need to plug in x, y, and m, and that's going to allow us to get b by itself. So y is 5, m is negative 3/2, and b is negative 4, excuse me, x is negative 4, and we're looking for b. So we need to simplify this part, and this is going to be the same process every time. Negative 3/2 times negative 4 is going to give us positive 6. So 5 equals 6 plus b. Then we need to get b by itself, so we'll subtract 6 from both sides. So we get negative 1 equals b. Now that we have b and we have m, we can write the equation of our line. Y equals negative 3/2 x, okay, the negative 3/2 came from m, minus 1, and that came from b. Number 2, same exact process. Okay, y is 2, so we have 2 equals negative 1/2 times negative 4 plus b. 2 equals 2 plus b. When we subtract 2 from both sides, we get 0 equals b. Remember, 2 minus 2 is 0. A lot of people mess up right there. Careless errors. They would write 1, but 2 minus 2 is 0. So when we go to write this, we have y equals negative 1/2 x plus 0. But we usually don't write plus 0, so y equals negative 1/2 x is all we would need to write there. For 3 and 4, these are really the same thing, only we need to find the slope first. So it requires one extra step at the beginning. Remember, slope formula is y2 minus y1 over x2 minus x1. Okay, so we just have to do that first. If you need to label these x1, y1, x2, y2, go for it. Okay, there's no reason not to do that if it helps you. So our slope is going to be negative 2 minus negative 5 over 3 minus 0. Negative 2 minus negative 5 becomes negative 2 plus 5. So that'll give us 3, and then 3 minus 0 is 3. So 3 over 3 is 1. Our slope is 1. Now we're ready to do what we did in the last problem. And it doesn't matter which one of these points you choose to use. Negative 5 equals 1 times 0 plus b. Well, 1 times 0 is 0. So negative 5 is our b. So now we can write the equation of the line. Y equals 1x minus 5. Again, we normally don't put the 1 in front of the x, so we would just write y equals x minus 5. Number 4, same process. x1, y1, x2, y2. So our slope is -3 minus 1 over 0 minus 2. -3 minus 1 would give us -4. 0 minus 2 would give us -2. When we simplify that fraction, we will get +2. So that's our slope. So if we use, I'll use the first point, 1 equals 2 times 2 plus b. So it's 1 equals 4 plus b, subtract 4 from both sides. B is -3. So I have y equals 2x minus 3. All right, for these last 4, again, it's almost the exact same process, only this time we're given a line that we're either parallel or perpendicular to. You need to make note of whether we are parallel or perpendicular. Remember, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So in number 5, we know that the slope is 3/4 because they're parallel. They have the same slope. So we can say -1 equals 3/4 times 4 plus b. -1 equals 3 plus b. So -4 equals b. So our line is y equals 3/4 x minus 4. Number 6, again, they're parallel, so our slope is 3. So we have 5 equals 3 times 2 plus b. 5 equals 6 plus b, subtract 6 from both sides, so b is -1. So we have y equals 3x minus 1. Now our last two are perpendicular. That means we need to use opposite reciprocal slopes. That means we change the sign and then flip the fraction upside down. Well, number 7, our original slope was -1. So when we flip that upside down and change the sign, we actually get 1, because -1 over 1 upside down is -1 over 1. Change the sign, it loses the negative sign. So we have 4 equals 1 times 3 plus b. So 4 equals 3 plus b, so 1 equals b. So we would go y equals 1x plus 1. Remember, we don't usually write the 1 in front of that x. So y equals x plus 1. And number 8, last one, our original slope is -3/4. We flip that upside down and change the sign. So our slope will be 4/3. So 3 equals 4/3 times 4 plus b. That'll be 3 equals 16/3 plus b. Don't use decimals here because you're going to have to round to do that. Keep them as fractions. Okay, we need to subtract 16/3 from both sides. That's going to give us -1/3. Nope. Let's pull out our trusty calculator and make sure we do this right. 3 minus parentheses 16 divided by 3. Remember, that's how we do fractions. They're just dividing problems. It's going to give us a decimal. We don't want decimals, so math, enter, we'll change it. So we get -7/3 equals b. So our equation, y equals 4/3 x minus 7/3. So even with fractions, it's the exact same process. So go back through these again if you need to. do a little bit more practice, study, get ready for that test. Good luck.